something as simple, I just want to change the color of an object, right? They, when we do these videos, we'll throw in like little tips like that as well, where I change the color, oh no, it didn't change, BIM is broken. And I've heard that so many times, the BIM does not work. Why not? Well, the thing didn't change color. And you go in there and look, well, yeah, it was that little view attribute setting thing that had to change. So, and we've built this library over the last, I guess it's been 8 months now, and just video after video of, what we do every day as modelers. Then, once we've identified what people have to see, then we have this coach, which we call the automation lead. Now, this is a role that we've invented specific for our projects, and what that means is, when we've got a team, every team will have pretty much all of these disciplines. Technology is probably our internal one. We create this automation role, and the job of this person, who's called a project automation lead, is to really just coach the other disciplines through the development of the model. So you want someone who will own the model. Now, this doesn't have to be a unique person. It could be somebody, like oftentimes the architect is the owner of the BIM. So the architect is there ensuring that all the other disciplines are sending the information in the way they want. But somebody has to be there. And what we have is that automation lead will develop a plan saying, this is our BIM for this project, and this is what it has to do. And they'll outline it. So if I want a simple BIM as an architect, my plan would say, I want my BIM to give me my drawings, to give me my door schedule, and to give me a finish schedule. And maybe a perspective. That's it. That's a definition of what BIM has to do. And I'll get that automation lead to sit down with my technician or the modeler or some of the engineering disciplines to say, this is the mission of what we want to do. This is what you guys have to do to help facilitate it, or to not hinder it. And we found that we'll have project managers who will say, I'm not adding that cost to my project. I'm like, okay, don't, no problem. Somebody's going to do it anyway, because no matter what, if I'm on my project, and then my project manager will say, no, we're not having your automation lead guy. All right, I'll still have to plan my BIM. I got to know what I want to do with my model before I make it. So it's really, if you think of it as a conceptual role, somebody has to plan what we want to do and why. We'll pause for questions.
Those videos, how widely available are yours? Can you use it? Can she use it?
No.
Why not?
Well, because
How good is that too? Did I get evolve that from scratch and rock and roll?
well, it's something that I think should be packaged. We could probably package and sell, right? And that's something I would say contact me after, because what we did with those videos is we actually sold the state of them to the London Olympics. This was back in December. So in December we just had how to use MicroStation, because the London Olympics are a MicroStation based program, and we sold them how to do basic 2D and basic 3D. So we packaged that and sold them off. Right now, no, they're only available in the CH network, but they are packageable. So anything else? I'm sure there's more. He's got I see him writing, he's writing down all the questions. Manipulation of BIM. So I'm going to play a couple of videos here, and then I'll just talk while they run. This is automatic clash detection. So one thing, by nature of having a model, and you can pull the model into Navisworks. I think Revit does this if all the models are in Revit. Bentley Building will do it if all the models are in Building. Or in Bentley, excuse me, but Navisworks will take any and all platforms, suck it into one spot. It'll identify what's interfering with what, and as you click on each interference, you're able to determine, well, what are the two components, and then you can ask yourself, why are they interfering, and are they supposed to be interfering? And if you see two items touching and they're supposed to be, and I'll keep using the column on a slab, or a foundation wall on a footing, they're going to be interfering with the same, the bottom of the wall will interfere with the top of the footing. That's an okay interference. Other items, like here, I think it's pipe in a wall, you can write a comment saying, this should not be interfering, engineer, have a look at it, and give that back to the disciplines. So you just cycle through, the program identifies any and all interferences, and you cycle through them and say, good, good, bad, bad, good. Now you can make rules. I'll just get this one going as well. This is from another vantage point where you can actually identify the interferences, and then you have full navigational abilities to actually drive around the interference and see, well, why is this interfering and is it acceptable? You can write rules specific to your software saying, if I have something that I called a wall, a column, and it's sitting on something called a slab, that's not an interference. And you can actually write that so the program understands it. That puts more of the onus then on the modelers to say, well, if I'm going to model a column, I better call it a column so that clash detection will know that it's allowed to sit on what I call the slab. If you don't do that, then any rule you think of writing won't apply. So from a conceptual perspective, clash detection, it's super intelligent, but it's super dumb too. It will look for anything that's touching and say this is an interference. If that works, that's okay. If it doesn't work, then you can actually get in your software and say, well, no, I want certain things to not be interferences, and you can write that into the tools. For design constructability review, again, there's the section, and we'll use companion files with the model to allow the viewers to understand, well, what exactly is my section showing? If this is all you use BIM for, this is probably the biggest benefit that we've had our clients and our project managers say. It just lets me see. They'll say they don't know what's happening in that section, but they could see what's happening in this view. Now, to get to this point, the fundamental BIM use, I would argue, would be make my drawings, let me have a look at the model. And that's probably what the clients recognize the most. Again, you can take snapshots of your model at any time. You can strip away facades to show what's happening inside. This was a huge processing plant for radioactive waste storage that we did here in Ontario. And the client didn't really care about the building. The client cared about the process that was behind it. How does this radioactive waste get dealt with? I cared about the building, but he wanted a view that didn't show the building, so we gave him the building as a shell. There's various drive-through tools. This one here I'm showing is Oracle's CAD view. There's Autodesk Naviswork. There's Bentley Navigator. The concept there is you're able to drive through the model. You can identify components. You can see what those components are. You can cut sections. I think that's what's going to happen here. So you can cut sections in any direction and then drive through those cut sections to give you the idea of, well, how's this thing going to look on my drawing? And then you can mimic that. Well, this is how it actually looks in a 3D perspective. And then you can do full rendered walkthroughs as well. So the previous one was just native components. Let me see how it looks, just the assembly of the 3D parts. This one here is a fully rendered walkthrough using DirectX engine. And this is done inside the MicroStation platform. And what it does is it reads all the material mapping and the rendering palettes and applies it to the components as you're walking through in a fully rendered mode. You'll see the refresh, it kind of skips on the refresh a bit because it's drawing so much graphical data while you're driving. And I'd say, going into your models, if you know you want that, plan for that. And I'll keep reiterating, if you guys are thinking, well, you're showing all this stuff, just where do I start? You just start with, I need a model and I need my drawings. Start at that point. Your drawings will come. I would argue that your drawings will eventually come quicker because that's the experience that I've seen. And then as your drawings come quicker, what I've noticed is, okay, now I can sit back and say, well, what more can I throw into this? Because my drawings are already there and the project manager says I'm doing great on his budget. So here's an example where this is a 3D PDF, and what that is you're able to take your model, save it as a PDF, hand it over to anyone to just drive through using Adobe Reader version 7 or higher. And it recognizes all components of your model. Here, the issue here was, this was for that same radioactive waste building, and the rebar required within the base wall where the tanks are going to be stored had to have this specific design requirement. The contractor and the structural engineer couldn't see eye to eye, so they asked us to actually model the rebar. So we did this as a post-design exercise, and we were able to deliver the 3D PDF to the contractor, complete with a couple drawings and details to show them what had to be done and why. And then the other possibility is to just use the model itself for viewing purposes. So here, this is something, all tools have this, and here it's called a clip volume, but it's basically playing with display depths in multiple directions. So you're able to just take pieces of your model, visualize it, see what's happening, and actually physically model in these spaces if you wanted to. And then of course you can save renderings out, save clippings as required. And the last one, this is another 3D PDF. And this was in the planning phase. So we finished the planning charrette, threw up the walls, threw in a ceiling, and then started plopping in the equipment. We were trying to play with the layout to make sure spatially we had enough space. And then the client said, well, you know, you have a model, let me drive it, give me a rendering. And we said, well, no, you can't have a rendering because I think we're in schematic design. There wasn't enough to render. So we saved the model to a 3D PDF. So it's just file, print, PDF. And in the 3D PDF, you can give it this SketchUp type look. So the client was able to do his drive through, get an understanding of what's wall versus ground versus ceiling. And again, a lot of these tools have full integration with SketchUp as well. I'm not sure how many SketchUp users we have here, but if we start with a SketchUp model, they can, elements of that model, before they weren't easily sucked into the BIM world, now that those walls are closing down with the interoperability efforts. So if you have a SketchUp model, it can go into MicroStation and I believe in Revit as well, or AutoCAD Architect, I can't remember which one. So you can now go from SketchUp to BIM and move forward and have the benefit of a lot of these review tools that I'm showing. For construction schedule simulations, here in your head you've got to think now, well, how is this thing being built? So when I say to the modelers, don't just model, think about the construction, and I get back, well, I have no clue how it's going to get built. So we send them out to site. So you need to have some time on site. You got to see how this stuff gets poured. You got to see how the steel gets erected. You got to see how panels go on. Because to facilitate this, again, all of these tools are inside all of the BIM tools. When I hear, well, you know what, you showed construction simulation, it doesn't work. Like, well, why doesn't it work? Well, all my steel shows up at the same time. Well, the reason for that is because somebody came in and they modeled a column that went from here to here. So when you want to animate that and put it in a scheduler, you can only schedule by component. If you know you want to do this, and they actually model the column in the 7 pieces, 8 pieces that are there, then you're able to facilitate, we're going to plan how this thing gets built from the bottom to the top. So that goes back to not only know issues around construction, but actually communicate with your engineers and communicate and think, well, you know, what's the planning? How are we going to build this thing? If it's a design-build project, that's the easiest way because you can have your contractor on hand and you can say, well, look, this is what we're going to do. Tell us how you plan on building it or how you think you may want to build it, and we can model accordingly. Here's a sequencing from a planning perspective. We were just doing a site plan arrangement, and we laid out, that's my colleague in Atlanta, we laid out how these buildings are going to come onto the site, showed it to the client, we had a Primavera schedule, and the client said, well, you've got a couple buildings coming in first, it's going to cause a block and we won't be able to actually facilitate the rest of the construction. So here we started, the client said try it in a different mode, so we flipped with our schedule and we were able to get the buildings in from a certain vantage point, allowing him to maintain access from the other side. So we were able to just iterate different versions or different models of how will this thing get built Do you want to start from the bottom corner up? Do you want to start from the back moving in? And the client was able to play with us and say, no, we need to do certain blocks at a time to facilitate this, and we were able to just by manipulation of the Primavera schedule affect what was happening with the model. And finally, this is what I alluded to earlier. For schedule simulations, you've got to have a concept of how it's going to get built. So, do I draw a big concrete slab, or do I draw 3 pours of a concrete slab? Will it be 3 pours? Will it be 5 pours? Will it be 10 pours? You might not know the answer, but from a suggestive perspective, you can sit back and say, we have a concept of how it may get built, and let's propose that to the client. Or you can sit down with the client and their potential contractor and say, if you plan on doing this, let us know, pay us to do this, and we can do this. Or if you want to buy the BIM from us, if it's a design bid project, we'll give you the model. Is there anything you need to make the client happy to facilitate that arrangement? So we go through that dialogue quite often, and many times we don't do this. So we'll just model that slab. It's much easier for me to model one slab covering the entire footprint of the building than having to think about how will this thing get poured, where are the we have no expansion joints, but where are the construction joints and the pour joints. Quantification is a huge benefit of, and it's really a byproduct of BIM. So when you open any of the tools, any of them out of the box, they have a mode of categorization. So when I go and draw a form, whether it's a wall, a slab, whatever it is, in Revit or Triforma or Graphisoft, there's a mode where I can say, I'm about to draw a wall, or I'm about to draw a concrete slab, or I'm about to draw a face brick. And once you designate that, and then you draw your form, you're able to quantify it based on how you designated your model. So there, we stress to users, don't put stuff in the model. You're not just drawing lines. It's more complicated than I'm going to put a line on a level. Now you're going to put a form on a level with a categorization. And this is where, the pushback I get from BIM is, well, you're just putting you're putting too much emphasis on how I draw this thing, so we don't want to do it. And then it's like, okay, well, don't do it, and we'll just move on to the next project. Because when they don't do it, then they come back 4 months later, hey, can you give us concrete volumes? Well, no, you didn't call anything concrete in the model. Or can you give us a visualization? Or can we drive through the model? Well, no, because we didn't do any of this stuff. So that graph I showed where we're pushing the hump earlier, we've got to have all the thinking and the decision making, and we've got to push those to the conceptual end, so that when we start to develop this model, we can sit down and say, well, what am I modeling and why, so that we're able to facilitate a lot of these benefits. This was the slide I showed at the beginning, geometry plus data. Oftentimes, and this happens a lot when we want to do, I'll use doors as an example. Put a door in the model. Well, we can put a door in the model, and they'll ask the architect, well, what's the particulars around the data? Hardware, fire rating, well, we have no clue because we're in schematic design. So the BIM has the ability to actually have placeholders for the data. So I can put my door in there and not fill out anything, but in my head I know I have to go fill it out eventually. So when I discover that that door is in an hour wall, I can go give it its 3/4 rating. When I discover that, hey, I'm going to use a hardware set, or I'm going to use certain closures, I can go back and insert it on that door. So you don't have to know everything, like you don't have to know the particulars of the data at the beginning, but you have to know that I will need data eventually. And that's the difference versus I'll just draw the door. The door is drawn for the duration of the project, and I'll come over here and do my schedule at the end of the day. No, I'm going to put my door, and that door will need information. I'm just not going to put it in there now because we're at the beginning of the project. An example of the quantification. So the software is able to actually divide what type of material you have based on its categorization. And no matter what your software is, so here we have cast in place concrete, and it can categorize beams, corbels, footings, etc. you're able to manipulate and tweak exactly what you want to see. So if there's a piece of concrete in there that we're not able to show, we can actually add that categorization for the next time we model. And then it gives a grand total. So if we decided to give this volume to the bidders, to include it in the bid documents, we would say everybody's bidding on about 13,300 cubic yards of concrete. That's what this is saying. That would just take away their need to quantify the concrete based on our plans, because we want them all to bid on this. Now, what if we're wrong? That's a huge problem, right? So this is why, and I'm not standing here saying we do it all the time, because we don't, because we're nervous about this. We've done it on a couple projects, and it's worked pretty good in the States. Now, obviously, we haven't done this on a Canadian project. That's why the example I'm showing is in Imperial. I think it was a water treatment plant for the Aurora Waterworks in Colorado. We gave them this and said, this is our concrete. Bid on this only. And I believe it was, plus or minus 1 to 5%. I can't remember what it was. So it was off one direction or the other, but it wasn't so critical because the number was this big. Now, obviously, if the number's smaller, your degree of error can't be that big. But if you're wrong, let's say there was 23,000, and somebody in the model just forgot to call it concrete. Let's say they called it brick by mistake. Doesn't show up here. We're missing 10,000 cubic yards of concrete. Huge problem. And I don't have a solution to that, other than we have to make sure the model is done good, or else this won't work. Same with the steel. We're able to quantify how much steel do we have based on its pounds, and same thing here. We have a number that we could give or not. We're able to quantify it by, we have steel tube, certain HSS section. So we can actually give them a count of sections, their lengths, and the weights of all the pieces of steel. But again, that's assuming that the structural modeler who put the steel in the model picked the right section. So picked an HSS 4x3x3 and meant to pick that, and ensures that every piece of steel was picked in the same manner so that it registers in this report. If I don't have the confidence of that with my modeler, I won't even propose this to our project managers. I'll say, just forget it. We can have internal quantities, so I can give this to a cost estimator when we do our bid cost estimate, and I could say, yeah, I think we have about 15,000 cubic yards of concrete. Take it or leave it. They'll go open our plans, they'll do their manual takeoff. Yep, that was pretty close. I'm like, well, who's right? No, that was close, and they go walk away. So I'll maintain, this is good. When the model is good, this is spot on accurate. When the model is not good, you've got problems. HVAC, you can actually get a complete count of all ducting and fixture types. Electrical, different types of lights, how many you have. Now the critical thing is, everything I showed you here, about 80% of it is default out of the tools that we receive. Electrical is very unique, because we sat down with our electrical engineers and said, well, what do you want to count, right? They go, well, our lights. I said, great, so do you want me to say you've got 200 lights? They said, well, no, we'd like to know what type of light. So they gave us their spec, and in the software, we just built a name for each and every one of those. So when I go and place a light, or an electrical modeler places a light, they just have to select which one of those 25 odd lights are they placing, and then we're able to get a count from it. Again, if they don't select the light type, we don't get a count. And then that's where BIM kind of breaks. And we don't want to do that. Same with the telephone. Yes, sir?
Is there anybody conversant to actually have handoff procedures for the model that can sort of provide a verification?
Well, do you mean on our project teams?
Yeah.
Well, that's the role of that project automation lead.
Mm-hmm.
So if you take the four-phase, the AIA four-phase, we've made checklists for architectural, structural, civil for each phase. We have a set of checklists for the automation lead. And part of that is, if you're delivering bill of quantities, it's part of their job to go in the model and have a walk around and see, well, if I look at the electrical model and I just select all and see that there's 80 lights, but my report shows only 20, go to that electrical discipline and say, okay, guys, there's an error, something's not showing up. So that's part of that. It's really a quality control role that we've built into the projects. And that's why I said, whoever wants to start BIM, if you sat down and said, the goal of our BIM is to do these 3 things, and I'll just keep doing drawing, schedule, and a rendering. Somebody, like once you've stated that goal, somebody on your project team is going to have to sit down and say, well, are we meeting that, right? And do a constant check-in. So if you want a rendering and it's looking horrible every single time, somebody's doing it wrong. Somebody set the wrong materials, applied it to the wrong whatever, and it's that form of quality check that needs to be built in. So when we do this, like this isn't a surprise. Like we won't hit the button and say, well, this doesn't look right, but we're going to bid tomorrow, nothing we can do. Like we hit this button throughout the project almost on a weekly basis. And as the model grows, the automation lead will look into this model and say, we are missing, we're showing only 10,000 cubic yards of volume of concrete, yet when I grab all of the shapes that are in the structural model, the program is telling me there's 30,000. So 2/3 of your shapes don't have information on them. So it's that kind of quality check we can do back and forth. I think we've got to take a break. So it says up to 15 minutes. Good question.
Almost dead on the line. Ron? I'll stop it.
Just throw that.